Okay, guys, here's number 5 of the Honors Unit 8 review packet. We'll start at the top. It says a trapezoid is blank a parallelogram. Well, in order to be a parallelogram, you have to have 2 pairs of parallel sides. In order to have to be a trapezoid, you can only have 1 pair of parallel sides. So a trapezoid is never a parallelogram. The 2 things can never overlap because one is only 1 pair of parallel sides. The other one is always 2 pair of parallel sides. Okay, a rhombus is blank a square. Well, a rhombus is a square, but a rhombus is not always a square. A rhombus is sometimes a square, specifically when all of its angles are congruent. Okay, a trapezoid is blank an isosceles trapezoid. Well, a trapezoid can be an isosceles trapezoid. It's not always one. So again, a trapezoid is sometimes, specifically when its legs are congruent. A quadrilateral is sometimes a kite. Remember, quadrilateral just means that all 4 of the sides are congruent. This is a quadrilateral specifically where 2 pairs of consecutive sides are congruent, so sometimes. Okay, let's do a proof. It says quadrilateral EFGH is a rhombus. Prove that EFK, we've done this one a lot, is congruent to GHK. Okay? Let's think of some things we know. For instance, because it's a rhombus, I know that these 2 sides are going to be congruent. So I can say that EF is congruent to GH because opposite, or I can say opposite sides of a parallelogram or a rhombus are congruent. I could have said all sides of a rhombus are congruent. It just needs to be a true statement that validates this. Okay, so let's keep going. I know that these will be congruent and that these will be congruent. So I could say that EK is congruent to GK and is congruent to HK because diagonals of a rhombus, or you could just say parallelogram because a rhombus is a type of parallelogram, diagonals of a rhombus bisect each other. Okay, well now I can say my triangle is congruent to my other triangle because of SSS. There's a lot of ways you could have done this one. You could have said that these 2 angles, their measures are equal because they're vertical, or they're congruent because they're vertical angles, or because diagonals meet perpendicularly. You could have done that. You could have proven that these 2 angles were alternate interior angles. You could have done that. Those 2 angles are alternate interior angles. You have a lot of options. This is just one way to do it. But in this case, I think you could have used SSS. You could have used HL. You could have used SAS. You could have used AAS. You could have used ASA. I think you could use all of them. That's pretty cool. Okay, let's look at the proof. The takeaway from this is one way to do it. It is not the only way to do it. Okay, we made a small mistake. We were copying this from an old proof and just forgot to delete that out. So I just rewrote that. We know that ABCD is a parallelogram, and I know the measure of angle B is 90 degrees. So I've already done this one. I'm just going to walk you through my steps. So here we go. Okay, we can say that the measure of angle B and the measure of angle D are going to be the same. They're both going to be 90 because opposite angles of a parallelogram are congruent. Okay. Really, I should have said angle B is congruent to angle D. That actually probably would have been better, but that's okay. Again, I know in LSs, at least for my classes, we've been really focusing on being specific in how we do our proofs. We talk about like math grammar. For this test, I'm much more worried about the concepts getting you from step A to step B than perfection in the proof. So I don't want you guys to stress out about that, which is why this would be totally fine. Okay, I also know that consecutive angles in a parallelogram are supplementary. So these would be supplementary. These would be supplementary. If angles are supplementary, then we know that means that their angle measures add up to 180 degrees. I know that the measure of angle B is 90 degrees, so I substituted that in, which means when I subtract 90 degrees from both sides, I get that the measure of angle C and the measure of angle A are both 90 degrees. Now, if you wanted to, you could just jump right to the bottom and say that we know it's a rectangle because a parallelogram is a rectangle if all 4 of its angles are congruent, or you could say if all 4 of its angles measures are 90 degrees. Again, there's a little flexibility here. If you were being really picky, which we've been working on a little bit in my classes, you might have added these 2 steps in, just indicating that all 4 of the angles were 90 degrees, which means that they're all congruent. So that's really what a rectangle is. It has 4 congruent angles. Not that their measures are equal, their angles are congruent, but there's a little flexibility here. You do need a way to show all 4 of them either have the same measure or are congruent, and then you need to make a statement saying that it's a rectangle. So at a minimum, I would need a step like this, a step like this. You would somehow need to get to this as well. You can't skip all of this, but the way you did this here might have looked a little different. It might have been a little shorter, and you need a step that looks like this at a minimum. And there should be something else in between. Okay, so I'm going to stop this. We've got one more video to do. So here it goes.